In this tutorial, we're going to talk about how to begin to make a dual-stick shooter on the Vita, and to be able to do that, we need to be able to read the state of the thumbsticks. So we'll talk about that. We'll talk about static methods, what those are and why they're important. We'll talk about how to draw a sprite in a rotated state, and then we'll finish off by talking about some trigonometric functions such as sine and cosine and atan2, and how those can be used when calculating the player's movement. Now, if you haven't done so or it's been a while, you might want to go back and review the videos that John Preston did for Computer Science 1. So before we begin, let's talk about some of our art assets. Now here you can see that we have an icon, and this is going to represent the player, but note the direction of the icon. It's pointing to the right. And the reason that that's important is because as we rotate it, to the right means 0 degrees. So also notice that we're using some trig here, and you'll see how it's applied in just a second, but the sine of 0 returns us a 0, and the cosine of 0 returns us a 1. Now if we were to rotate this player around, notice that the sine of 90 is going to return us a 1, and the cosine of 90 returns us 0. If we continue on, you can see that the sine of 180 returns us 0, and the cosine of 180 returns us negative 1. And then finally, the sine of 270 returns us a negative 1, and the cosine of 270 returns us a 0. Now you may be asking, what's the big deal? Well, if you pay close attention, you'll notice that the cosine of the angle relates to the x part of the movement. The same thing is true for sine. The sine of the angle relates to the y part of the movement. Now what do we mean by this? If, for example, we have an angle of 0 degrees, notice that the cosine of 0 returns us a 1. So we're going to increment our x position by 1 pixel. The same thing's true for sine. If the sine of 0 returns us a 0, we're not going to change our y position at all. Now imagine that now the angle is 90. You can see that the cosine of 90 returns us 0, which means that we're not going to move our x position at all, which makes sense. And the sine of 90 returns us a 1, so we're going to decrement our position by 1 pixel, meaning that we're going to move up 1 pixel on the screen. Alright, so if we jump over now to the PlayStation Mobile Suite, you can see that I have begun to build a project here. In this case, I'll just call it TUT1. You can call it whatever you want, but make sure that you have this checkbox selected here, Create Directory for Solution, and then you can click OK. Also make sure that you're building a PlayStation mobile application. Okay, so you can see it creates a directory structure like you've seen before, and we have a couple of shaders that we're actually not going to be using, and we also have app main. It's also a good idea to go ahead and add a folder here. We'll call this one assets. Alright, and I actually already have the assets ready to go. So let's do this. We'll dive into tutorial 1. You can see that the assets folder is here. And over here you can see that I have an assets folder that contains some assets that we're going to be using. So what I'll do is I'll just copy these and paste them into the assets folder. We also have zombie 3, so I'll move that guy over. Okay, if we go up a little bit, we could go into the shaders directory of our project, and you can see that we have two shader pieces here. We have the fragment shader and the vertex shader, but we're going to be working with a different one that I've modified slightly that's going to allow us to do some really interesting additive blending. So let's copy these guys and move them over. And then finally, if we go back up here in the same directory as appmain.cs, I'm going to take our new Sprite class that I made, and we'll move that over. And this is really where the changes are. I'm actually using the same shaders for the most part. Alright, so let's go back to the IDE, and we'll do a couple of things. Now, I like to start projects out by querying how big the screen is. So let's create a couple of variables here, static int, and let's call it screen width, and we'll also say screen height. And then we can query this graphics variable here right after it's been brought to life. I could say that the screen width gets graphics.screen.width, and do the same thing for screen height, gets graphics.screen.height. Okay? Now, I'll go ahead and try to create this sprite here. It's going to cause an error, but let's go ahead and try it. So we could say public sprite, and notice that it can't find it. So there's a couple of reasons for this. The first thing is we haven't imported anything into our project. We moved it over in the file system, but we need to do the same thing here in the IDE. So what I can do is to add this file right here. You can see that Sprite is now available. So now I should be able to say public static Sprite, and you can see that it's recognized by the system. Okay, so let's create the background sprite, and this is actually going to be the grass texture. So let's go ahead and bring this background sprite to life. So I'll drop down here into the initialize section. Now notice that we haven't imported any of our assets, so let's go ahead and do that. It's a really common thing to forget. So I'll add all of these, say open, and if I were to open the assets directory, you could see that those are there. And before I forget, I'm going to go ahead and add these new shaders that we have as well. So add file, and you can see that we have the Sprite shader right there. So we should be good to go. All right, so as we said before, let's drop down here. I'm going to bring this background sprite to life. So I'll say background sprite gets a new sprite. And notice that it wants a graphics, which we have, and it wants a texture. So let's hold off on that for now. I'll say texture 2D backtext gets a new texture 2D, and it wants the name of the file. So that's going to be application/assets/ and I'm going to use this grass texture small. I'm going to do this on purpose. It's not going to fill the screen, and so we're going to have to handle that later on. And then the second parameter here is I'll pass false. Okay, so we now have enough information to bring the background sprite to life. I'll pass it graphics as well as that backtext that we just loaded. Okay, the last step that we need to do is to drop down here, and I can tell that background sprite to render itself. So let's go ahead and do that. And if I were to run it, you can see that we have a partially filled background. Well, this is no good. What I really want to happen is for this texture to fill the entire screen. So you could say, well, fine, I'm just going to hard code it. I'll go into paint.net or something like that and expand it out manually, but let's try a different approach. So I'll shut this down. So one of the things that we'll want to do is to determine the scale ratio of this texture to the screen. So what I'll do is I'm going to fill in some extra information about this background sprite. First thing is to set the position and make sure that the x and the y position are 0. So we can say background sprite.position.x and y get 0. All right, so now we have to figure out the scale. Now, how are we going to do this? Let's create a couple of variables here. Float, and I'll call it scale x, or how about x scale? That's a little bit better. Gets a float version, and we're going to do the ratio of the screen width over the background sprite dot width. And what this is going to do is it's going to even things out so that it essentially tells us the scaling factor. A scaling factor could be something like 1.5 or maybe 0.75 or something along those lines. In other words, how much we should stretch it through the screen. All right, so we'll do the same thing here for the y scale. It's a float version of the screen height divided by background sprite dot height. Great, now that we have these ratios, I want to fill the scale value of the sprite. So here I'll say background sprite dot scale, where is it there, scale dot x gets the x scale. And we'll do the same thing here for background sprite scale y gets the y scale. Now, what impact is this going to have? Well, if I run it again, you can see that we now have the entire screen filled with this texture. But at this point, it's a little bit grainy. You can see it doesn't look that great. So to overcome this, what I'll do is I'll get rid of this small. Like I said, I did that on purpose. And if I run it again and it's a little bit higher resolution of a texture, it looks just a little bit better. All right, good. So now we have a background. All right, so the next thing that we're going to do is to create a player class. So I'll shrink these down for now. And I'll right-click on this project space and say add a new file. In this case, I want an empty class called player. Now, the first thing that I'm going to do is to grab these using statements. I like to get everything here, even this collections generic, which we'll be playing around with in later tutorials. And I'll come back over here to the player class and paste those guys right there. All right, now a player is a form of a sprite, but we're going to wrap the sprite with extra information about where the player is, such as their position and their velocity and whether or not they're alive and all those kinds of things. So the first thing that I'll do is to come up here inside the class but outside of the constructor and say that we have a private sprite, which we'll just call sprite. We'll also create a Boolean, and we'll call this one isAlive, and of course this is going to determine if the player is still alive. We'll jump up here and create a public vector3, there it is, pause. Now you may be asking why we're using a vector3 as opposed to a vector2. It's just going to keep us from having to typecast later on. We're really not going to be using that z component of the vector3. All right, public float rot, because we want to be able to rotate this player around. And then also I like to have something with regard to speed, because a lot of times you have to scale the player up or down with regard to speed. So we'll call this one, yeah, I guess just speed is fine. And we'll set it at 2.0 for now. All right, so the constructor of the player, I'm going to set it up probably slightly different than what you've seen before. We're going to take in this graphics context and we'll call it context. We'll also take in a string that's going to represent the texture name. In other words, I'm not going to actually pass the texture, I'll just pass the name that we want to use. And then finally this vector 3, which will cause pause. Now notice that we have a class variable here called pause, and we also have a parameter here called pause. So the question is, how do we differentiate between these two things? Let me get rid of that extra curly brace. Okay, so I'll show you how to do that in just a second. So for now, let's say that text, we need a texture. Let's create a temporary texture here. Texture 2D text gets a new texture 2D. And notice that we can just pass it the texture name and also this value false, like we've seen before. Okay, we want to bring the sprite to life. So let's say that our sprite gets a new sprite, and we can pass it the context as well as the texture that we're going to load. So that looks good. Is alive is always going to start out to be true. We'll say that this dot pause gets pause, and this is what I was referring to before. If I want to talk about this pause that's up here, in other words a class variable, I can say this dot pause. If I want to talk about a local variable here, in this case a parameter, I can just say pause. So essentially what I'm doing is taking this pause and filling it with the information that's coming in as a parameter named pause. This keeps you from having to do weird things like putting underscores and all that other kind of nonsense that you might have seen before. Okay, so this dot pause gets pause. Let's set the rotation to 0 to begin with, 0.0f. We'll also set the sprite center variable x to be 0.5. And this is going to be really important. If you don't do this, it's going to rotate around the upper left-hand part of the texture. In other words, you're going to have this kind of circling that's going on, and that's not what we want. What we're saying with this sprite.center.x is equal to 0.5 is that we're going to use the midpoint of the texture as the rotation point. All right, so we'll drop here and also say that sprite.center.y gets the same value, 0.5f. Okay? Also, because this is a wrapper for a sprite, essentially, we're going to say public void update. And in this case, I'm going to accept the gamepad data. And we'll call it gamepad data. So that's good. And on the inside, we can do a couple of different things, but for now, let's just say that the sprite.rotation is going to get rot, and the sprite.position is going to get pause. And we just need to make sure that we're updating that sprite on the screen to begin with. One last function that we'd like to put in here is public void render. And so I'll do this, and I'll just tell the sprite to render for now. Sprite.render. Okay? This might be a good time to go jump over here to Sprite and just show you some of the changes that I've made. The first thing that I did, essentially what I did is I merged the code from a couple of different examples that came with the documentation. And so I added in this float rotation variable here that's accessible here. You can see we used it actually right here on line 32 in the player class. So we'll come back over here and look at this. So I added that. Let's scroll down just a bit. I added some region here. I like regions so that I can shrink things down. And then if you look at render, this is really where a lot of the work is going on. So I commented here, beginning of the new stuff, and the end of the new stuff is right here. And I have a couple of other comments that we'll be playing around with later on when we get into particle systems and whatnot. Okay, so if you look, you can see that we're doing some calculations with trigonometry. Notice that there's an fmath class that we're using instead of math. I think it's an optimized version that works with floats. But I've calculated the new positions of the sprite polygon. I'm not going to get into the math behind that, but essentially it's done some linear algebra light, and it just works. Also notice that down here in line 182, you can say graphics.enable, and you pass it this enable mode.blend. And then we also have to call this graphics.setBlend function, and we have a couple of different ways that we can do this, and for now you can see that I've just used additive blending here, blend func mode, and I might change this a little bit later on in this example so you can see what's going on. The rest of it's mostly the same. All right, good. So the player looks pretty good so far, so let's jump back here to app main, and then I'll drop down here and let's create a player. Okay, so to be able to do that, I'll say public static player, and we can call the player hero for now. And then if I drop down to the initialize section, just after I messed around with this background text, I'll go ahead and bring that player to life. And to do that, I'm going to have to pass it a couple of different things. I'm going to have to pass it not only the name of the texture that I want it to load, but also the position. And the reason that I say that is because if we go back to the constructor, you can see that I pass it the context, the name of this file that I want it to open, as well as the position. So let's get all that stuff set up here in app main. All right, so the first thing that I'll do is to create a temporary vector3, and we'll call this pause, gets a new vector3, and let's put the player initially at 200 over, 200 down, and 0 for the z coordinate. All right, so let's do this. We'll bring that hero to life. Hero gets a new player, passing it the graphics. The next thing is the name of the texture. In this case, it's going to be application assets, and then what did we call that guy? I think it's hero. Yeah, it's hero. So hero.png, and then we'll also pass it false. Oop, no, not false. We'll pass it the position. So that looks good for now. And we'll drop down here. We'll want to tell the hero to update. So I could say hero.update, and I pass it the gamepad data that we've already pulled. So gamepad data. In other words, we pass it what we have already done here as the default code into that update so that we can use that for detecting thumbsticks and whatnot. Okay, the last thing is to tell the hero to render himself. So hero render, and notice that I did that after I've rendered the background sprite. That's an important step. And let's see what happens when I run it. So now you can see that I get this kind of semi-transparent character that's on the screen, and the reason is because I did turn on that additive blending. So this is just one of the modes that we have. If I move around with the gamepad, you can see that I'm not really getting anything, and I know you can't see me moving around the thumbsticks, but trust me, it's not working. So we have a couple of different changes that we'll want to make. So what I'll do is I'll jump here into Sprite, and we'll dive around and play around with some of these functions here. But you see this original one? That's the one that you're going to be working with most of the time. So I'll uncomment that, and I'll run it again, and you can see that we get something that's much more opaque. And that's exactly what we want in this case. Now, when we get into particle systems that have smoke and fire and all those kinds of things, we'll change those settings in later tutorials. All right, good. All right, so now you may be asking, well, when do we finally get to see the thumbsticks? So let's jump over here to Player, and remember, Player has the ability to take in this gamepad data when you call update, and that's really where the power is. So let's jump over to Player, which we've already done, and let's start to mess around with the thumbsticks. So to be able to do that, what I'm going to do is jump up here, and you can see that we've updated the sprite rotation and sprite position, but we do that usually as a last step. So to change the player's position, what I'm going to do is I'll say that pause.x plus equals gamepad data dot analog, and notice that when I type analog that I get analog left and I get analog right. In this case I'm really working with analog left, so I'll say analog left dot x here, and what's going to happen is I'm updating the player's position based on the feedback that I'm getting from the left thumbstick. Specifically, I'm getting data that's in the range between -1 and +1 from the left thumbstick. So I should be able to move around the character based off of what's coming in from the gamepad. I'll do the same thing here, pause.y plus equals gamepad data. And again, if I type in analog, you can see that I have a couple different options. In this case, I will say analog left y. So we're just going to plus equal those things together. And at this point, I should be able to run it, and you can see that because I've changed pause, I'm actually changing the position of that sprite as well. So I'm moving around the thumbstick, and this is the left thumbstick, and you can see that my character is moving around on the screen. If I move the right thumbstick, clearly nothing is going to happen because we haven't programmed that yet, but I'm moving around the right thumbstick here and nothing is happening. So let's go ahead and work on that part. So to be able to do that, we have to get into a little bit of that trigonometry that we saw earlier. So the first thing that I want to do is I'm going to store the analog signal that's coming from the right stick into a couple of different variables, and I'll explain why in just a second. So I'll say float stick x gets gamepad data dot analog, not left this time, analog right x, and I'll do the same thing here for stick y. And notice that I'm keeping these in separate variables. So in this case, I'm putting the analog right y into stick y, and the analog right x into stick x. Now the reason that I have to do that is because I have to calculate the angle of the right thumbstick. To be able to do that, this is where we're going to use our trig. So I'll say float angle gets fmath, I'll use that new library, fmath, dot atan2. And atan2 is a wonderful function, but realize that the IDE, at least in its current state, is a little bit messed up. When I pull up the parameters, you see how it says float x and float y? Well, those are actually backwards. You almost always pass atan2 the y position and then the x position. Same thing is true here. So I'm going to pass these backwards from what it actually recommends and say stick y and then stick x. And this is going to give me the result that I'm looking for. Okay? So immediately after that, I could just go ahead and assign the rotation to be angle. And if I were to run it, I'm going to get something that's not exactly what we're looking for. It's close, but it's not exact. Okay, so I can move the left thumbstick, and you can see that this does move the position of the player. And then I can also aim around. I'm just doing a circling motion here with the right thumbstick. But as soon as I let off, notice that it snaps back. And that's not really the behavior that I want. But they are independent. You can see that I can kind of strafe around here if I want to do something like that. And the speed is a little bit slow. I'm getting kind of a bad frame rate right now, I think because of the recording. So let's go ahead and fix that. I don't want this snap back. That's not any good. So what I can do is I can check the values of stick X and stick Y. And I can say only update this rotation with the angle if you're getting something off of that right stick. So what would that look like? I could say if stick X does not equal 0, or stick Y does not equal 0, then it's okay to go ahead and update that angle. Right? So we can go ahead and move that angle information over into ROT if there's something that is existing from the right stick. What can happen is as soon as that right stick is in its resting position, the values for stick X and stick Y go to 0, and therefore the angle goes back to 0, which is not what we want in this case. Okay, so if I were to run it now, you can see I can move around, and I could let off the stick, and you can see that it stays in the direction that we need it to. So that's it. We've seen a couple of different things. The last thing that I really want to talk about is how I called this function right here. Notice that I could just say fmath.atan2. This is called a static function, and what a static function is one that you can call by prefacing it with the class name and not having to create a new instance of it. Let me say that again. So for example, notice that I didn't have to create a new instance of an fmath. I didn't say fmath, my math gets a new fmath. I didn't have to do anything like that. I could just say fmath, the class name, followed by the static function name here, atan2. So it really makes sense to use this if you have situations where it doesn't make sense to bring to life a new instance of that class. And fmath is a perfect example of that. So that's it for now. You can see that we've made quite a lot of progress in this example. We're going to extend this out and include things like particle systems, and we'll get into inheritance and polymorphism and how those things can be applied to this game.